Then next one is curative. Okay, can someone give some preventive methods and curative methods quickly? What are ecological? Hygiene and sanitation, that is a preventive method. Mechanical, that is a curative method. Hygiene, yes. Aeration, physical method. Irradiation, proper stacking. Legal, okay. Okay. Structures and all cultural methods, yes, yes, good. So last, only one thing, the botanical methods, only one thing is remaining, that is chemical method. Due to time constraint, I couldn't finish it off in the last class. I will finish it off and move over to the topic, assigned topic for today. So one thing was remaining was chemical control, and I will ask one more question, whether according to our law, whether mixing of insecticides is permitted or not. No, yes. So for chemical method, we shouldn't go for mixing of insecticide. We can only go for surface treatment. That means treating the walls, floors, etc. Or we can go for spraying on the bags, outside the bags. So can someone name the insecticides recommended in storage? Malathion, malathion. Any other? Any other? Deltamethrin, yes, deltamethrin is one. Bifenthrin, it's not recommended, and DDP will be banned. So this much we have studied. Then we have a lot of elements. We were discussing about fumigants. Fumigants are widely employed for insect pest management in storage, because what is it? We keep grains in a confined space, because usually a godown, uh, we are keeping it in a confined space. It's not as an open field as we cultivate rice, wheat, vegetables, or any other thing. It's a confined space. So in a confined space, we can completely cover the structure and go for a fumigation. Because fumigation, if it has to be effective, the entire structure needs to be airtight. I will repeat, for fumigation to be effective, the entire structure needs to be airtight. If it is not, if you keep any fumigant outside, it will release gas and it will move out in the environment. It's gone. It won't have any lethal effect on the environment. But if you are releasing that particular gas into a confined environment, then it will make a difference. It will cause mortality of insects. So several fumigants are widely used. One of the most widely used and still recommended fumigant is aluminum phosphate. Do you remember the aluminum phosphate which I had shown you in the IPM class? We have an aluminum phosphate tablet. Yes or no? No, no. Let me see if I have one. No, it's not there in my table. Usually, I used to have one tube of aluminum phosphate. I will show you in the next class. Okay, how it looks like. You should know how a aluminum phosphate tablet should look like. So that's available. That's available in the market, and any person, a PSC agri graduate, can all use it. Then we have carbon tetrachloride, ethylene dibromate, EDCT. ED is nothing but, I will type it: ethylene dichloride, carbon tetrachloride. Ethylene dichloride, and it's a mixture of two gases, carbon tetrachloride. So it's ethylene dichloride and carbon tetrachloride. We abbreviate it as EDCT. and we have another one, methyl bromide. Among this, I have given only a few. Because you are BSc Agri students, you need not learn all the, because we have at least 20 to 30 fumigants which were used or which are currently used. But the most widely used one still is aluminum phosphate. It is an age-old fumigant. Carbon tetrachloride, ethylene dibromide, and all uh, are used in between, but it's not that widely used. Methyl bromide was the one which was most widely used earlier, methyl bromide. But the problem was methyl bromide, that bromine, that halogen is a ozone depleting substance. That's why we banned chlorofluorocarbons in refrigerant as a refrigerant in refrigerators, air conditioners, and all. That's why whatever fridges or air conditioners that you purchase usually have a tag of CFC free. So, as it is an ozone depleting substance, this methyl bromide use was banned in our globally, not in our country alone. Globally, it is banned. In our country, it was banned from 2015, and that global ban was based on an agreement. It is called as Montreal Protocol. I am typing it over. It's called as Montreal Protocol because if you have you heard about Paris Summit or the Paris Protocol for Climate? I think I might be remembering. If you have followed some international developments for the last 2 weeks, you might be remembering. Yes, then why, what is Paris Protocol or Paris Summit? It relates to, it's related to environmental issues itself, climate change. Oh, yes, environmental climate change. Yes. Once Trump became president, he withdrew from Paris Accord. Now Joe Biden will return. US will return once the Joe Biden becomes president again. So that's the thing. In the same manner, earlier in Montreal, there was a climate summit, and in that climate summit, it was agreed to remove all ozone depleting substance from use. And by 2005, all the developed countries withdrew the use of methyl bromide. And by 2015, all developing countries and underdeveloped countries withdrew the use of methyl bromide. So methyl bromide was one which was widely used, but nowadays it is not used. So we will discuss mainly about aluminum phosphate because that's the one which is mainly used. You remember about aluminum phosphate and give the examples of this. Whenever you, if you write methyl bromide, it should be with, it is banned. Okay. And in aluminum phosphate, it is available as small tablet. We have two tablet size. One is 3 gram tablet size and other one is 12-gram tablet size. So this 3-gram tablet looks like the one you purchase some glucovita. ഇല്ലേ നിങ്ങൾ മെഡിക്കൽ സ്റ്റോറിലൊക്കെ പോകുമ്പോൾ എന്താണ് ഗ്ലൂക്കോവിറ്റയുടെ അങ്ങനെ ഏതാണ്ട് ഒരു മിഠായി പോലത്തെ സംഭവം മേടിക്കില്ലേ, ചെറിയ വട്ടത്തിലുള്ള, എന്താടോ അതിന്റെ പേര്, നിങ്ങൾ വാങ്ങിച്ച് മിഠായി പോലെ കഴിക്കുന്ന ഒരു സാധനം ഉണ്ടല്ലോ, അല്ലെങ്കിൽ പോളോ മിഠായി കണ്ടിട്ടില്ലേ? യെസ്, it is having the size of that polo toffee which we usually take, but there is no hole inside it. So that's the thing, it's a solid, completely solid one. The size and thickness almost, it's almost the same as that of, but it is completely black in color. I will show in the, hopefully I have a sample of it. Otherwise also I will procure it and show it. It looks the same size as that, that of that polo or that glucovita kind of thing. And it is perfect black in color. So that is 3-gram tablet. And this 12-gram tablet has the size of the carom board striker. നമ്മൾ ക്യാരം ബോർഡിൽ ഉപയോഗിക്കുന്ന സ്ട്രൈക്കർ അല്ലേ, that's a bigger one. It is having the size as well as thickness of that carom board striker. So that is 12-gram tablet. Only the contents and all same, but the composition may vary. But size also varies, 3-gram and 12-gram tablet. But whatever it may be, this 3-gram and 12-gram tablets releases, each tablet release 1 gram of phosphine gas. I forgot to mention it in the uh, slide, you note it down. Each tablet, whether it is 3 gram or 12 gram, each tablet release 1 gram of toxic phosphine gas. I have written it in the chat box. So remember, each tablet, whatever be the size, 3 gram or 12 gram, releases 1 gram of phosphine gas, and the dose recommended is 1 to 3 tablets per ton. Usual recommendation is 3 tablets per ton. Usual recommendation is 3 tablets per ton. So what we will do is, if we stack 1 ton of grains in a godown, 1 ton usually say 50 kg bag means it will contain about 20 bags. So we have a stack of 20 bags. We will completely cover that stack with air without any damage free sheets, and that sheet's thickness is specified. I think it is 250 gauge. 250 gauge thick polythene sheet. The entire stack will be completely covered, and inside the polythene sheet, we will keep these 3 tablets in different locations. We will keep these tablets, this toffee kind of thing, in a paper and keep it in between the bags, and we will again cover the sheet, and at the bottom also we will seal, so that the entire stack will become airtight. You understood how a fumigation is done? The entire bag will be covered. We will calculate, say 1 ton, 2 ton, 3 ton, whatever it may be, the quantity which we store. We can calculate the dose. If it is 2 ton, keep 6 tablets, cover the sheet, take each tablet in a piece of paper, any base paper, keep these 6 tablets in different locations of the stack, cover it properly with a sheet. That plastic sheet should not have any holes or any damage, and at the bottom part you should keep, either nowadays what we will do is we will fix a tape over it, that wonder tape, that brown colored insulation tape which we normally use. We will seal the edges or borders. It will be airtight. We will keep it for 5 to 7 days. So this tablet will release phosphine gas. This phosphine gas can't escape into the environment because it is covered with that plastic sheet, and this gas spreads all throughout the bags, and it will kill all the insects. So that's the practice. So are you clear how we go for phosphine fumigation, aluminum phosphate fumigation? Yes. Okay. So this is remember about the equation also. Aluminum phosphate, the molecular formula is ALP. Aluminum phosphate, ALP. Is ALP reacts with water. Water means there is no need to spray water and all. It can absorb moisture from the atmosphere. So there is no need for spraying water and all. Aluminum phosphate can absorb water vapor, that is sufficient for it. It reacts with 3H2O and it will release phosphine, pH3. That's why this arrow, as you all know, this is gaseous form. So aluminum phosphate, it is solid, absorb moisture from the environment, 3H2O, release pH3 phosphine. Oh, this it's wrong. It's wrong. It is ALOH thrice. It is ALOH thrice. Just a minute. I will just correct it and show you. Is it clear now? Is it clear now, the equation? As in chemistry class, I will ask whether the equation is balanced. My wife is a chemistry teacher, so now she takes classes from home itself, and every now and then I used to hear this question to the students. whether the equation is balanced or not. So that's why I'm repeating it again, whether the equation is balanced or not. Its equation is balanced. So okay, fine. So that's the thing. That is chemical method. Remember about fumigation. It's a thing. And last one is engineering method. In engineering method, we have a term called as hermetic storage. Just remember about the term hermetic storage. Hermetic storage is nothing but airtight storage. Hermetic storage is nothing but airtight storage. So remember what happens in a airtight storage. So what happens? Can someone note it down? What happens in a hermetic storage or airtight storage? Carbon dioxide increases and oxygen content decreases. The same thing. So this is we are finishing off storage. That's the thing with storage. And I will conduct two quizzes in Moodle. I don't know whether I will be able to set questions this week. I will try because I have some engage tasks to complete within this week. Hopefully, I will try to do it this week itself. I'll give 2 to 3 days gap. Try to conduct it. I won't make it compulsory for, but try to go for it. Just go through the slides. I am uploading all the classes again in the Moodle. If you want to go through it, listen it again and again and attempt it. It will be always a multiple choice kind of thing. You can leisurely take it. This will improve your understanding. So that I will do. Then next, we will go for today's topic, that is public health pest. Uh, so, what do you mean by public health pest? What do you mean by public health disease? What kind of disease? Contagious diseases. Okay. Any insect which has a role to play in any human disease. So that is public health pest. From this class onwards, I will complete my portion within by next class. Hopefully, by next class, I will try to finish it off. And this is, you just have to understand the things. We don't usually expect very big questions from it, but listen to it. It's pretty easy to understand. There is nothing much difficult to understand in all these things, all the things which you might know. So can you name a few public health pests? You can list out. Mosquito, yes. Rat, okay. We don't discuss about rat in this course. Cockroach, housefly, fly. Few more ticks, yes. Then tsetse fly, yes, good. What about head louse? You forgot it. So there are so many. We will discuss at least a few. There are few minor ones which we don't normally see it over here in our country, but it is serious outside. Uh, so I am presenting my entire screen because I need to show one website in between. Okay. Are you able to see my presentation? Yes. Okay. So the first one, first I will cover flies deterrence. Though it's not, I am covering flies alone in the first. Some deterrent public health pest I have added in at the last. So that will come at the end. But still, I will cover mostly diphtheria, public health pests, because these are the largest group of public health pests. And the first one which we will discuss is moth flies and sand flies. Have you ever seen an insect like this? This one. This is moth flies or sand flies belonging to the family Psychodidae. This is common in our area. We usually see this is very small flies, but it is used to congregate on the walls. And sometimes we used to see it in hostels and all. Has someone seen it? Yes, yes. Then it's good. So here it doesn't cause any damage in our part, but it's a vector of a disease called as sandfly fever, or it is also called as leishmaniasis, because the sandfly fever is caused by an organism called as leishmania. So that's why it is that disease is also called as leishmaniasis. It's also called as sandfly fever. And moth flies and sandflies belonging to the family Psychodidae are vectors of this leishmaniasis or sandfly fever. The next group is black flies, or the family is Simulidae. Moth flies or sandflies belong to the family Psychodidae. Then black flies belong to the family Simulidae, and these black flies are blood-sucking in flies, and the females only are bloodsuckers. So black flies are blood-sucking insects, the females, and during that blood-sucking process, it transmits a disease called as river blindness or onchocerciasis. It transmits disease called as river blindness or onchocerciasis, and this disease is caused by this onchocerciasis or river blindness is caused by nematode Onchocerca volvulus. Onchocerca volvulus. So it's a vector of the nematode Onchocerca volvulus. If this Onchocerca will cause river blindness or onchocerciasis in human beings. But again, this we normally not does not see in our area. The black flies are there, but it doesn't transmit the diseases in our area. So moth flies and sand flies belonging to the family Simulidae, and black Psychodidae, and black flies belonging to the family Simulidae are not that serious, though it is present in our area. It's not that this is transmitting insect in our area. Psychodids transmit leishmaniasis and simulids transmit onchocerciasis. So the next one is mosquito, belonging to the family, as you all know, it belongs to the family Culicidae. And this is the most important public health pest all over the world. It's the most important public health pest. And if I ask you what are all the diseases transmitted by the mosquitoes, I should not list out what I have written in the slide. You people know what are the diseases transmitted by the mosquitoes and which genus of mosquitoes transmit which diseases. That all you might have studied in your plus one, plus two biology courses. So normally we have three species of mosquitoes, three genus of mosquitoes: Anopheles, Culex, and Aedes, that we all know, Anopheles, Culex, and Aedes. Anopheles is the one which is a vector of malaria, and Culex is the one which transmit filariasis or elephantiasis. What is filariasis or elephantiasis? What is filariasis or elephantiasis? മലയാളത്തിൽ പറയുന്നത് എന്താ? Month, yes. Have you earlier it was pretty common. We used to see people with filariasis. Have you ever seen a person with filariasis, elephant foot now? For the last maybe 7 to 8 years? Yes. Oh, still okay. Because government is spending a lot of money in distributing. Amrita says she hasn't seen distributing that albendazole tablets. As in school, during school and your college day, you might have received albendazole tablets. That is nothing but for preventing this filaria spread. So Culex is the one which transmit filariasis or elephantiasis. And the last one, Aedes, that is the most dangerous one. It is a vector of yellow fever, dengue fever, chikungunya, etc. I forgot to mention chikungunya at the second point, but later on I have added it over here. So malaria is transmitted by Anopheles, filariasis by Culex, and Aedes is one of the most dangerous one, transmit yellow fever, dengue fever, and chikungunya. So that these all things you know. And as you all know, only the adults are terrestrial. All other stages, the eggs are laid in water, the maggots as well as pupae are aquatic, and only the adults are terrestrial in nature. So all the egg, maggot, pupae stages are aquatic in nature, and don't think that if water, especially for Aedes, it doesn't require standing water at all. It needs only an extremely thin film of water to lay the eggs. That is the survival capacity of Aedes. Anopheles and Culex is not like that. It requires a bit of standing water. But Aedes, it doesn't require that standing kind of water. It needs only a thin film of water for its egg laying and survival. And you might be knowing the larvae or maggots are called as wrigglers. Have you ever seen mosquito maggots in any stagnant water? You might have seen. And what is the motion? Yes, it wriggles around. That's why it is. It doesn't stay in a static mode. It moves around. It wriggles around the stagnant water. That's why these are called as wrigglers. So these mosquito maggots are called as wrigglers, and pupae are called as tumblers. Pupae are called as tumblers. This term may be a new that you remember. The pupae are called as tumblers and they are coma shaped. That's what I have seen it over here. This is the pupae of mosquitoes. This just looks just like a coma. So mosquito pupae are called as tumblers and which are coma shaped. And adults, only the, as you all know, only the females are blood sucking. But even the females, during the first 3 to 5 days, they feed on nectar. Then only it starts feeding on blood. So only the females suck blood, and the females for the first 3 to 5 days they feed on nectar. And regarding egg development, there is slight difference between certain mosquito species. Certain mosquito species starts egg development only after receiving the first blood meal. That means only after sucking blood it starts egg development. And that kind of mosquito species are called as anautogenous. Anautogenous. While there are certain other species which automatically have egg development and there is no prerequisite for a blood meal before egg development. There is no precondition that it should have a blood meal before egg development. And that kind of species, mosquito species, which can initiate egg development without any sucking blood from any organism, and they are called as autogenous because their egg development is automatic or autogenous. There is no precondition that it should have a blood sucking event before initiating egg development. So that is called as autogenous, but most of the mosquito species are anautogenous because automatically it can't initiate egg development. Only once it receives blood from an host, then only it will body will initiate egg development. That is called as anautogenous. Are you clear regarding autogenous and anautogenous? Yes. Okay, now we will see the differences. I think you might studied the differences between Anopheles, Culex, and Aedes in your biology classes. Again, I will slightly repeat it over here. It's pretty easy to understand. We have the three characters: egg, larvae, and adult. Pupae, there is no much difference between the three genus. That's why pupae is not listed over here. And again, in the active periods, there is slight difference. That's why we have the active period listed at the last. And regarding the eggs, Anopheles and Aedes mosquitoes lays their eggs singly, while Culex mosquitoes lay eggs in a group, in a clump. So Culex differs from Aedes and Anopheles in that Culex mosquitoes lay their eggs in a group or a clump, while it is laid singly in Anopheles and Aedes, and the egg clump of Culex is called as egg raft. The egg clump of Culex is called as egg graft. So that is one thing. And for Anopheles, these eggs are having some air-filled compartments on the eggs to help the eggs to float over the water surface. That is absent in Culex and Aedes. I will show a picture of it. See, this is Anopheles. You can see some air-filled compartment over here, and this helps the eggs to float over the water surface. So it is laid singly. And see Culex, there are numerous eggs laid, and this is called as egg raft. മലയാളത്തിൽ റാഫ്റ്റ് എന്ന് പറയുന്നത് എന്താണെന്ന് അറിയാവോ? വാട്ട് ഇസ് കോൾഡ് as a raft? ഒരു മലയാളം വാക്ക് റാഫ്റ്റിന്റെ ചെന്നാടം. Yes, that's the typical word. So it looks like a raft. Now you can understand a bit better. So this is the difference in the thing. Legs are laid singly in Anopheles and Aedes, but in Anopheles we have air-filled compartments or floats. In Culex, it is laid in clump called as egg raft, while egg floats are absent in Culex and Aedes. And with respect to larvae, I will show the picture and have it. Okay. You see it over here. See the Anopheles larvae. This is the water surface. The larvae lies parallel to the water surface. The body of the larvae will be parallel to the water surface. But see the case of Aedes and Culex. The larvae will be lying diagonal to the water surface. This is Aedes, this is Culex. So the larvae will be lying diagonal to the water surface. And you can see a breathing tube over here which will help to breathe from the atmosphere for air exchange of atmospheric gases. So this breathing tube is longer in Culex, but it is short in Aedes and Anopheles. So that major difference is lava is lying parallel to the water surface in Anopheles, while it is diagonal in Aedes and Culex. While in Culex, the breathing tube is elongate, while in Aedes and Anopheles, it is smaller in size. Respiratory tubes are short in Anopheles and Aedes, while it is in Culex, it is long. And see the larvae rests horizontally on water surface, that is parallel to the water surface, suspended from the water surface diagonally. It remains at diagonal to the water surface. And head, it is smaller in Anopheles and larger in Culex. That I don't have a better picture of it. And with respect to adults, I will show that picture. See, in Anopheles, see the Anopheles, in the case of adults, it is different. In Anopheles was lying parallel or horizontal to the water surface. But see, the adult Anopheles is entirely opposite to that. It sits at an angle with the surface. While the Culex adults, it lies parallel to the surface. Whereas the maggots were lying diagonal to the water surface. So Culex adults and maggots differs in their position. Anopheles adults and maggots differs in their position. Anopheles adults lie at an angle to the surface, while Anopheles maggots lie parallel to the water surface. In the case of culex, it's just opposite. Culex maggots lie diagonal to the water surface, while the culex adults are parallel to the rest, while parallel to the surface. Aedes also, it's almost like, can you identify this adult, which is the species, which is the genus? Can someone? This one. Yes, it's Anopheles. What about this one? Culex. What about this one? Aedes. Okay. Now, see, the Aedes, the color pattern, it is just like black and white lines, black and white patches. So that is the typical character of Aedes mosquitoes. In Anopheles, see the wings. The wings are having some dark patches. Can you see the wings are having some dark patches? That is the color difference. So, adult, I told you, Anopheles sits at an angle to the substrate. Culex is almost parallel to the substrate. And Anopheles, I have shown you the wings are having dark spots over here. You can see dark spots. But Culex wings, it's now there is no spot on the wings of Culex. While Aedes is having black and white patches all throughout the body. Then Anopheles and Culex mosquitoes are mostly active during early morning and evening. We call it as crepuscular insects. Crepuscular insect, I think you might have studied. These Anopheles and Culex mosquitoes are active during the early morning and in the late evening. While Aedes is entirely different from that. It is perfectly diurnal. It is active during daytime. While Anopheles and Culex mosquitoes are crepuscular. I think you know what is crepuscular. The insects which are active during uh, early morning and evening, dawn and dusk. So that's the difference between Anopheles, Culex, and Aedes. That is pretty easy to understand. You can go through it. Just a minute. Okay. And many of you might be wondering what attracts mosquitoes to some person. Yeah, if you uh, compare different persons, mosquitoes are always attracted to certain persons compared to others. uh, because I am not that attracted to mosquitoes, but my other family members, especially my wife and all, she is highly attracted to mosquitoes. So I usually tell, if you are sitting beside me, I usually escape from mosquito bites. There are several factors associated with it. One, the attractants for mosquitoes include carbon dioxide, then lactic acid, that is especially if you have some physical activity. Say you did some exercise, you went for some sports or games activity, your lactic acid content in the body will increase. That will be attractive to the mosquitoes. And third one, that is a volatile thing, octinol. Octinol, this octinol released from our body is attractive to mosquitoes. So there are several things, but the major ones are carbon dioxide, lactic acid. This lactic acid accumulates in our body after some physical activity that you all know. Then optinol, that is an attractant released from our body which attracts mosquitoes. And annoying flight and buzzing sound, that you know it is what creates most of the problem for even other than bite and transmission of diseases. Its buzzing sound is the one which creates a lot of nuisance to it. And coming to the management is also pretty easy for you. Just go through it and try to avoid exposure during peak mosquito activity. Aedes we can't avoid because it is diurnal, extremely diurnal in nature. But for Culex and Anopheles, try to avoid exposure during early morning and late evening time so that we can avoid exposure to Anopheles and Culex mosquitoes, and we can provide mosquito screens window in windows doors etc. That way നമ്മൾ കൊതുക് കയറാതിരിക്കാൻ വാതിലും ജനലിലും നെറ്റ് അടിക്കുന്നത് പോലെ. So provide screens in doors, windows and ventilators. Then we can use mosquito nets. And in FAO, under United Nations, not FAO, WHO, sorry, WHO is supplying mosquito nets impregnated with synthetic pyrethroid insecticides in African countries, especially in resource poor market African countries where malaria is a serious issue. So, in order to reduce the mosquito related problems, especially malaria, WHO supplies mosquito nets impregnated with synthetic pyrethroid so that even if a mosquito sits onto that mosquito net, it will get killed. So, that is the one which is, I haven't seen any mosquito nets impregnated with synthetic pyrethroid in common use. In India, I had seen this used by army personnel, because in army personnel they don't have a perfect building and all. They usually reside in camps. So in that camps and all, they will be army provides them bed net impregnated with synthetic pyrethroid, so reduce the mosquito problem. And then we can use repellents like DEET. DEET, you might be remembering about Odomos, that cream. If you have a coating of Odomos on your body, then mosquito bite will be reduced. That is a repellent. Check the tube of Odomos and find out the content in that. It is usually diethyl toluamide. I will type it over here. Sometimes it is diethyl benzamide, diethyl toluamide. That's called as DEET, abbreviated as DEET. So you can check in Odomos what is that. So avoid exposure during active hours, provide mosquito screens, then use mosquito nets, use repellents. Then we can go for organized control. That's what we normally adopt in certain areas, especially by panchayat, corporation authorities, etc. If we have some mosquito related disease outbreak, say dengue fever outbreak in some locality, uh, these health authorities will come over to that area and completely organize a complete mosquito disinfection campaign in that area. And in Kerala, before every monsoon, government organizes some pre-monsoon cleaning. This is to avoid breeding sites for mosquitoes. മഴക്കാല പൂർവ്വ ശുചീകരണം എന്ന് പറഞ്ഞുകൊണ്ട് നിങ്ങൾ പത്രത്തിൽ കണ്ടിട്ടുണ്ടാവും, പ്രീ മൺസൂൺ ക്ലീൻ. So that is all part of organized control. The society has a role to play. So in an organized manner, we can have a campaign to reduce mosquito related issues. Then we can go for habitat modification, avoid water stagnation, especially in North India and all, in Delhi and all. It is a criminal offense to provide water stagnation in some locality. Especially they will come, the health authorities will come over to inspect in our household, and if they find any water stagnating in the water coolers, you might have seen water coolers, it is pretty common in North India, and water coolers use lot of water and water stagnates in that water cooler. If they find out water stagnating in any water cooler, there will be hefty fine will be imposed. Even water is found stagnating in a flower pot or something, they will impose fine. So avoid water stagnation, that is a habitat modification technique. Then we can go for biocontrol with mosquito fish. The scientific name is Gambusia affinis. So what is in Malayalam of Gambusia affinis? Everyone might be knowing that. Just asked. Guppy. Yes. So we can go for rearing of mosquito fish or Gambusia fish. There is one killfish. I don't know what is that fish. Fundulus. And one biocontrol method is the bacteria Bacillus thuringiensis, but it's not Kostaki. It's Israelensis. So BT israelensis is the biocontrol the bacteria used for the management of specific management of mosquitoes. So remember about BT israelensis. Don't write Bacillus thuringiensis alone. Write BT israelensis. Genetic control. I will discuss. I will show the website of it. Then we will discuss. Then chemical control. Chemical control. We can go for two kinds of chemical control. We can either target the maggots or we can target the adults. For targeting the maggots, we can use larvicides in water, we can use insecticides in water, we can either use malathion or methoprim. You might have seen municipal authorities or corporation authorities spraying insecticide in drains. So that is applying mosquitoes in water, larvicides in water. So the insecticides commonly used are malathion and methoprim. And for most adult management, we can use fogging that you might have seen, foggers, fogging insecticide. Then normal low volume or ultra low volume spray, even high volume sprays are also used. And what sorry, the normal pesticides used are pyrethroids. Just a minute. So the most common pesticide used for managing mosquito adults are pyrethroids. So it can be used either in a fogger or in sprayers. For use in water, we use malathion or methoprim. So management: protect your body, avoid during exposure during active hours, provide mosquito screens, use mosquito nets, use repellents with an organized control so that in a society can reduce involve together to reduce the mosquito population. Avoid any water stagnation. Biological control, you can use fish or BT silences. Then chemical control and genetic control is gaining more and more prominence. So I will show you, I have given a link, but I will show the website. There is a website called as debug.com. Debug, I will show that. Are you able to see my uh, browser now? Yes. This is the website of Debug, DEBUG. And this Debug is a company owned by Verily, Verily. You can see Verily. And both Debug and Verily are companies under Alphabet. Have you heard about the company called Alphabet? Yes, what is Alphabet? Google. Have I discussed this before? For some batches? No. Okay. So this is a company owned by none other than Alphabet or Google. So this is their website. This is the homepage of that website. It looks like this. Let's stop bad bugs with good bugs. Bad mosquitoes spread disease. Good mosquitoes can stop them. And I will show you. This is, I think you can see this how we stop bad bugs. You can go into this website and see it. I will show you how they do it. This is Wolbachia is a microorganism. So this Wolbachia, you can see that this Wolbachia, if this microorganism Wolbachia infects mosquito, it will make the mosquito sterile. So it's a kind of sterile insect technique. But here we are not irradiating, as we you might have studied about that screwworm fly and all. Here we are not irradiating. Here we are using a microorganism which has the capacity to make the insect sterile. So we have made mosquitoes sterile. So we need huge number of mosquitoes to release. So they have developed, this is a diagrammatic representation, cartoon kind of thing. So here they have reared millions of mosquitoes. They have the capacity has to rear millions of mosquitoes. But the problem with rearing is that once we rear millions of mosquitoes, half of them will be uh, females and the other half will be males. So what they do is they have a mechanism to separate out males and females. I don't know how they do it. Some people has the opinion that they are using some computer based algorithms to separate out male and female. They have not disclosed how they are, because that is the most critical part, how to separate out male and female mosquitoes. So they remove all the females and separate out all the males, and these males will be made sterile using the Wolbachia, and this sterile male will be released into the environment. And once the sterile males are released in the environment, now you can imagine what will happen. It will reduce population. So it's not theoretical. Say a sterile male and female will mate, it won't lay eggs. So this is the project all about, and this is not a theoretical one. This they are practically using it. Their pilot study has done 2 years back in New York City alone. I don't know whether last year they have repeated it. They after that they said they will be repeating it again every year. I don't know how what is the status of the project now, but this is the concept with respect to genetic control. So remember this: since Google is involved, it's not a small thing. We can expect this to come in a big way. So, are you clear? Yes or no? Yes. Okay. If there is several videos of it, you go to it. Anything else? Any doubts? Because time is over.